Dear friends, welcome to EPG Pathshala. I am Dr. Nitesh Goyal from DAV College, Chandigarh. I am going to present before you the 26th module titled Correlation and Regression Analysis under the paper Tourism and Hospitality Research. The module will cover the following topics: the introduction, measures of relationship, types of correlation, the coefficient of correlation, simple regression analysis, the time series analysis, and the summary. Dear friends, after the completion of this module, you will be able to understand the meaning of correlation analysis, understand the meaning of regression analysis, understand the meaning of time series analysis. Also, you will get an insight into the application of these three tools of analysis and comprehend the relationship and utility of the three. First of all, dear friends, I would like to give you a brief introduction about the topic. Till now, you must have got quite well versed with some of the basic tools of classification and analysis of data. The measures of central tendency like mean, median, mode, and measures of dispersion like standard deviation, mean deviation, etc. are used for univariate population, that is, on the population that comprises of measurement of one variable only. But if the data comprises of two variables from the population, it is termed as bivariate population. Further, if there are more than two variables in the data, the population is termed as multivariate population. Thus, when we have to measure a variable, say x, there is another corresponding variable, say y. The combination of the variables so obtained is termed as bivariate population. To add further, a third corresponding variable, say z, or the fourth, say w, and so on, it is then termed as multivariate population. In other words, for one variable, we use the term univariate population. For two variables, we use bivariate population. And for more than two variables, we use the term multivariate population. As once said by Albert Einstein, everything in this world is relative. It is very important to study two or more variables. One can understand the value of one variable only if there is another variable to compare with it. Hence, it becomes interesting for the researcher and the reader as well to have an insight into the relationship between the variables under study. Let us now take these analyses one by one, starting with correlation analysis. Correlation analysis is that statistical tool which is usually used to explain the degree to which one variable is related to another. Thus, the relationship, if any, is generally used to be the linear one. This kind of analysis is used quite occasionally with regression analysis. The word correlation actually refers to the interdependence between the two variables. For example, when demand of a certain commodity increases, the prices also tend to increase. Also, when the demand decreases, the prices also decreases. Now, this is the relationship between the demand of that commodity and the price of that commodity. Since both are going in the same direction, that is increasing or decreasing, it can be said that the relationship between them is positive. This kind of relationship can also be established for other variables also. The theory by means of which quantitative connections between two sets of phenomena or two sets of variables are determined is called the theory of correlation. On the basis of theory of correlation, one can easily study the comparative changes that are occurring in two or more variables along with their cause and effect relationship. However, it should be kept in mind that the relationship like black cats bring bad luck and other such things cannot be explained by the mathematical solutions of the correlation analysis. Pause. For correlation analysis, it is very important that the two variables should have a cause and effect relationship among them. If such a relationship does not exist, one should not undertake the correlation analysis. For instance, if we start comparing the height of students and the height of trees, the correlation analysis may bring out some of the values, but they will be of no use since they do not have any cause and effect relationship, as the height of students does not affect the heights of trees. Similarly, the height of trees does not affect height of students. Hence, there is no point of calculating the correlation analysis in this example. It is important to mention over here that the correlation in case of variables that relate to natural sciences can be reduced to absolute mathematical terms. Say for example, the heat increases with increase in light. However, in the variables that relate to social sciences, it generally becomes quite difficult to establish such absolute relationships between the two variables. Thus, it is always suggested that in social sciences, we must take the fact of correlation that is being estimated if in the large number of cases, the two variables and the study will always tend to move in the same or the opposite direction. Now, let's take on the different types of correlation. The correlation between the variables can either be positive or negative. Now, to know whether the correlation is positive or negative entirely depends upon the direction in which the two variables are moving. If the two variables are moving or changing in the same direction, then it is said that correlation is positive. However, if one variable increases and the other decreases, they are moving in opposite directions and hence termed as negative correlation. The negative and positive correlation can be presented graphically and known as scatter diagrams as presented here. First, you can see the figure of positive correlation. The second is the figure of negative correlation. In the first diagram, you can observe the slope, which shows that it is moving from bottom left to top right, that is upward sloping. This kind of slope is a positive slope, indicating a positive relationship between the variables. On the other hand, as in the second diagram, it can be observed that the slope is moving from top left to bottom right, that is downward sloping, indicating a negative slope. It should also be noted here that the points nearer to the slope shows higher degree of correlation, whereas if the points are scattered, they show a very low degree of correlation, whether they are positive or negative. Further, if the points are very much scattered and unable to draw a slope, it is then stated that the variables are unrelated. Now we come to the calculation of correlation, which is said to be the coefficient of correlation. The coefficient of correlation, which is denoted by small r, is one more important tool which describes how one variable is related to another. The coefficient of correlation actually measures the degree of relationship between the two related variables. The value of this coefficient always remains between +1 and -1. Here, the +1 denotes a perfectly positive correlation and -1 denotes perfectly negative correlation. And in case there is a value that comes out to be 0, signifies no correlation at all. All other values between 0 and 1, whether positive or negative, will signify their magnitude of correlation among them. If there is, for instance, a value of correlation 0.83, it signifies that there are 83% chances that if one variable changes, other variable will also change. Similarly, if the value comes out to be +1, it signifies that if one variable increases, there are 100% chances that the other variable will also increase and vice versa. The Karl-Pearson's coefficient of correlation or the simple correlation. This is the most widely used method of measuring the degree of relationship between two variables. Firstly, that there is a linear relationship between the two variables, signifying that there will be a straight line if the collected data are plotted on a graph. Secondly, that the two variables are causally related, which means that one of the variable is independent and the other one is dependent. Thirdly, a large number of independent causes are operating in both variables so as to produce a normal distribution. According to Karl-Pearson's, correlation can be calculated as below. It is summation of xy divided by n into standard deviation of x and standard deviation of y. In case we use the assumed means, that is ax and ay for the variables x and y respectively, then the Karl-Pearson's formula becomes as shown in your screen. In this formula, summation dxi is equal to summation of xi minus assumed mean x, summation dyi is equal to summation of di minus assumed mean y, summation dxi square is equal to summation of xi minus assumed y, summation dxi square is equal to summation of xi minus assumed x square, and summation di square is equal to summation of yi minus ay square, summation dxi into summation dyi is equal to summation of xi minus ax, that is assumed mean of x, multiply by yi minus ay, that is assumed mean of y. N is the number of pairs of observations of x and y. The next important topic is of the probable error. Probable error is of great use for interpreting the true value of coefficient of correlation. It is worked out as 0.6745 multiplied by 1 minus r square divided by under root n. After obtaining the value of probable error, it is compared with the value of coefficient of correlation. If the value of probable error is found to be greater than correlation, the value of correlation is not significant. The next is the Charles-Spearman's coefficient of correlation, or it is also named as rank correlation. Many a times it has been observed that the data are not available in numerical form for applying a correlation analysis, but still sufficient enough to rank the data in an order, that is as first, second, third and so on. In such kind of a situation, rank correlation method comes to the rescue and becomes the most appropriate method to calculate it is a measure of association that is based on the ranks of the observations of the data. For the purpose of calculation of coefficient of rank correlation, the first thing that is done is that the observations are replaced by ranks. The first rank is assigned to the highest value and so on, till the last value of the series is assigned with a rank. In the last step, the formula is applied to calculate the coefficient, that is as shown in your screen. It is 1 minus 6 summation di square upon n into n square minus 1, where n is the number of paired observations. The value of Spearman's rank correlation coefficient will always vary again between +1 and -1, where the plus sign is positive sign, indicates the positive correlation, or it can be said that the variables under the study are moving in the same direction. That is, if one variable increases, other will also increase and vice versa. On the other hand, the minus sign indicates that the variable have a negative relation, or it can be said that the variables under study move in opposite directions. That is, If the one variable increases, other will decrease and vice versa. Further, +1 indicates a perfect positive correlation between the two variables. All other values of correlation coefficient that lies between plus minus 1 will show different degrees of correlation. Suppose we get R is equal to 0.82, which suggests a substantial positive relationship between the two variables. Next, coefficient of determination. Statisticians have developed two different measures for describing the correlation between two variables. These are called the coefficient of determination and coefficient of correlation. The coefficient of correlation has already been discussed and coefficient of determination is presented here now. The coefficient of determination is symbolically denoted as R square. It is a measure of degree of the linear association of the correlation between the two variables, namely x and y, where one of the two variables will be independent variable and the other will be dependent variable. The coefficient is based on following two types of variations. Firstly, the variation of the y values around the fitted regression line is technically known as unexplained variation. Secondly, the variation of y values around their own mean is technically termed as total variation. Now, if you reduce the unexplained variation value from the total variation value, the outcome will be known as unexplained variation. In other words, the total variation is the sum total of explained variation and unexplained variation. The coefficient of determination is that out of the total variation of by which is explained by the regression line. In other words, the coefficient of determination is actually the ratio of explained variation to the total variation in the y variable related to the x variable. Now we come on to the simple regression analysis. The term regression was used by Sir Francis Galton in the year 1877 for the first time. He explained the concept with an experiment that showed that the height of children born to tall parents would tend to move back or regress towards the mean height of the population. He explained the term regression as the name for the process that helps in forecasting one variable change due to the change in another variable. He also coined the term multiple regression, which explained the process where more than one variable is used another variable. Here in this case, the variable to be forecasted is termed as dependent variable and the other variables are called as independent variables. Regression analysis was also explained by Blair as regression analysis is a mathematical measure of the average relationship between two or more variables in terms of the original units of the data. Hence, whenever there is a well-established relationship found between the variables, whether two variables or more variables, it becomes possible for the researcher to use this relationship in drawing out some calculations and help in forecasting the value of one variable, that is the dependent variable, on the basis of the other variable, that is the independent variable. For instance, a marketing manager may forecast his total advertisement expenditure on the basis of demand. Similarly, a tourism agency may try to forecast the total facilities to make available on the basis of the footfall of the tourists. On the same pretext, a new hospital can find out the correct number of beds required on the basis of the population of the town or that city. Hence, the researcher may apply the regression analysis technique to prove his theory that one variable having an effect on the other. This is also called as cause and effect relationship. The basic relationship between two variables can be explained through a mathematical equation called as regression equation, as you can see on your screen. It is y is equal to a plus bx, where y is equal to estimated value of y for a given value of x and a is the constant. The above equation is stated as the regression equation of y on x, signifying that with a change of every unit in x, there will be change of y by b. Some assumptions to regression analysis. While conducting the regression analysis, it is always assumed that there is a real and actual relationship between the two concerned variables, that is, the dependent and the independent variables. Another assumption for the regression analysis is that the dependent variables are random. However, the values of independent variables remains constant without error. Next, there is a clear indication of having a direct relationship between the variables. This means that the two variables must be somehow concerned with each other, and unrelated variables won't show good regression results. Another assumption for the regression analysis is that when the regression model is being used, the relationship between the two variables has not changed since the regression equation was initially computed. Lastly, the regression analysis can only be applied in case to predict the values within the range and not for the values which are outside the range. Let's now take on the relationship between the correlation and regression analysis. Regression analysis is a tool that is applied to evaluate the variable and predict the future events. It defines the relationship of the correlation between the two variables, which are termed as independent or the dependent variables. The regression analysis can be conducted for partial correlation as well as the multiple correlation. And in case of regression analysis, coefficient of correlation between any two variables are termed as quantitative index of association between the variables. Now, when the coefficient of correlation is good, it is termed as coefficient of determination, which is actually the variance between the variables x and y. Hence, the multiple regression analysis is that statistical tool that enables a researcher to evaluate the effect of different factors pertaining to the study on the consequences that it may have on the dependent variable. It analyzes the relationship between several independent or the independent variables and the one dependent variable point. The correlation analysis and the regression analysis go hand in hand and complement each other. The correlation analysis tells us the direction in which the variables are moving. It tells us the chance of change in one variable due to change in another variable, but keeps silent about the magnitude of that change. This silence is then broken by the regression analysis. The regression analysis tells us the quantum or the magnitude of that change in the dependent variable due to a specific change in the independent variable. Now friends, we'll take on the time series analysis. Time series analysis is a technique where the future is forecasted on the basis of the past values. Whenever we have to forecast future on the basis of the existing or the past data, the junction is taken that future is entirely based on present. The classical approach for analyzing the time series in terms of 4 different types of variations that may influence the time series. These types are secular trend, cyclic fluctuations, seasonal variations, irregular variations. Let's take them one by one. First, the secular trend or the simple trend. The secular trend is general long-term movement in the time series value of the variable say y over a long time. Here, the variable is the factor that is being considered while evaluating the future of this variable. Could be say population, etc. Trend is a term which is very commonly used in our day-to-day life, also like population trend, price trend, birth rate and so on. These variables are observed over a period of time and any changes according to it are recorded through time series. Now, there can be many trends like increasing trend, diminishing trends or stagnation, the stable trend. These changes occur due to a number of factors. The number 2 variation is the cyclic fluctuations. The cyclic fluctuation explains the frequent swings or patterns that are repeated over a long period of time. These fluctuations are considered cyclic only if they occur after certain time intervals of more than 1 year. These changes can occur due to the economic conditions, where in the economy may go into boom or may go towards some depression. In a boom situation, the economy will go up, and in depressing situation, economy will go down. The cyclic conditions suffer from certain limitations also, like the cyclic variations are not very regular. These cyclic variations or fluctuations may also occur due to some irregular and random forces which cannot be separated totally or avoided, and their impact cannot be measured separately. The third variation is the seasonal variation. Seasonal variations are the patterns of the changes that repeat over a period of say 1 year or less. This means that as against the cyclic variations, seasonal variations are of relatively shorter period. For instance, the sales of consumer items tend to increase due to any festivals like Deepavali, as there is a tradition of giving gifts. The sales of automobiles in the northern part of India is much higher in the months of April and May due to harvesting season. Following are some of the factors that may cause seasonal variations, like the season and climate. Because of the changes in the climate, there is a deep effect on sales. For instance, the sale of umbrellas in India is always higher in the month of monsoons. Similarly, in the months of winter, there is high demand for the woolen clothes. So, due to this reason, the climate does bring in the seasonal variations. Another seasonal variations could be the customs and festivals. As mentioned just now, there is a tendency of people buying more in the months of Navratras and during the Deepavali. On the other hand, Indian population does not like to buy in the days when the Shraddhs takes place. Similarly, during the month of June and July, the sale of new clothing, stationery items and laptops increases because this is the time when most of the admissions are done in the colleges. The fourth variation is irregular or random variations. These variations are unexpected or they occur just because of the chance. Thus, such fluctuations become completely unpredictable. Friends, after having a detailed note on the 3 tests, the correlation, regression and time series, it is now the time to wind up. The present module is an insight into the relationship analysis among the variables. One variable may itself be capable of being analyzed, but its true value can be known only when it is compared with some other variable. Hence, this module presents the 3 tests: the correlation analysis, the regression analysis and the time series analysis. All the 3 techniques present the relationship of the variables. The first 2 techniques are worked upon 2 or more variables of the same population, whereas the time series analysis is conducted on the same variable over a period of time. The correlation analysis presents the direction of the movement of the variables, whereas the regression analysis quantifies that movement. Time series analysis compares the current values of the same variable with the past values so as to estimate the changes that have occurred over a period of time. Thank you.